Class, am I audible to all?
Yes, ma'am.
Okay. Class, where did you write? Till where did you write in the last class? Was this written? This first part, was it written? Yes, Maniba?
Yes, we did right.
Okay. And the second case?
Yes.
Okay, this was also done. All right. Okay, thank you, Maniba. Aisha and Marwa, are you free tomorrow at 8:30 IST?
Tomorrow, chemistry, 8:30, it is finishing.
So after that? Okay, let me see. Chemistry class is there tomorrow, no? And check. Okay, if this is done, let's come to the numericals class. This is you are given two converging lengths of focal length 1.25. So the objective, see, now it's not mentioned objective or eyepiece. So what did we discuss? That you will have to use the whole concept that objective lens is greater, is of the greater aperture. Okay, so this will be eyepiece. Sorry, this will be here eyepiece is of the greater aperture. So objective lens will be the lesser one, which is 1.25 centimeter. FE is 5 centimeter. It says find angular magnification if least distance of distinct vision and U naught is given to us as 30 centimeter. See, for finding out the angular magnification, M is equal to V naught by U naught 1 plus D by FE. See, class, everything we have except V naught. So V for calculation of V naught, we have F naught and U naught. Using the lens formula, we can calculate it. So if I apply the lens formula, I'll get 1 by F naught is equal to 1 by V naught minus 1 by U naught. Now here I'll have to insert the sign convention. This will be negative. So 1 by V naught will be 1 by F naught plus 1 by U naught, which will be 1 by 1.25 minus 1 by 30. So this you will have to calculate what's the value of V naught. Insert V naught here. The rest of it you don't have to put any value. Okay, you don't have to put any sign convention, sorry. Second part is angular magnification, that is V naught by U naught into D by Fe. So same thing, class, you'll have to calculate the value of V naught first. So calculate V naught, tell me what's the value of V naught coming. Write it. This is for the compound microscope class. No, not 1 by V naught. Tell me V naught. You're getting it as 1.3. Okay, 1.3. If it is so positive or negative. Anyways, here you'll have to put in the sign without the sign convention. But what's your answer? Plus 1.3? Okay, then. So let me move to the next question. This is a similar question. It says that two converging lengths of focal length 1.25 and 5 centimeter are present. Okay, to design a compound microscope. If it is desired to have a magnification of 30, if magnification is 30, it says find out separation between the objective lens and the eyepiece. This is basically length of the microscope. Okay, if you remember, we discussed no, you're not by L here. I think I discuss this with you. No, we haven't discussed this. See, here basically, no, the length of the microscope. Okay, we haven't discussed this no first. See, length of the microscope is to be calculated here. For the length of the microscope, this term, no, V naught by U naught, this term is replaced by L by F naught. Length of the microscope means the separation between the eyepiece and the objective lens class. Okay, this is known as the length. Length of the microscope means the tube. So this is it. Okay, so V naught by U naught is L by F naught. So formula of yeah, see here, formula of magnification will be this. Objective is there. So this is the length L. So V naught by u naught is equal to L by F naught. Now L is missing, rest everything is already given. See, magnification is 30. L has to be calculated. D will be 25 centimeter. FE is given as 5 centimeter. FO is given as 1.25 centimeter. That will be your answer in centimeters. Okay. See, what's the answer coming here? And just add this length of microscopes concept.
Ma'am.
Seventy-seven and 64 for okay, first one 77 and second one 64. Okay, I'll just check and tell you the right answer there. Okay, meanwhile just try this. Zainab, are you sure this was your answer? It's mentioned as 96 and 80.
I did twice. I got the same answer.
Getting the same answer. Okay, maybe here the answer mentioned is wrong. Your mentioned answer is 96 and 80. I'll just calculate myself and I'll confirm you. Okay. If you're getting it twice. Muniba, your second answer was absolutely right, 6.25 for the length. One more question. Yes. See, this says that a compound microscope uses an objective length of focal length 4 centimeter, an eye length of focal length 10 centimeters. So, focal length FO and FE both are given.
Ma'am,
U is also given to us. UO is given. Same kind of question class. I hope by now you'll be able to mention it. This is the last question from compound microscope. We'll move on to the telescope and optical instruments. We'll finish. See what all we have. Remember class, for optical instruments formula, don't put the sign convention. Okay. For the lens formula, when you're using in between, then you put it. Okay, but just for putting the lens, putting the optical instruments formula, magnification, whatever it is, don't put in there. So here we will have focal length of the objective as 4 centimeter, eye lens as 10 centimeter, UO is 6 centimeters. First it says formed at the near point. Near point means least distance of distinct vision. Okay, so this will be separation only. No, you've calculated. L is the separation. 6.25, no, that you've got. That is the separation only, no?
but between the objective lens and eyepiece.
Yes, that is the length.
Okay.
Objective lens and eyepiece. Between both the lenses, is what we consider as the length of the microscope. Okay, that is what the length. I think I wrote it in the figure. This one, see, objective and eyepiece, their separation. When the microscope tube is constructed, the rest of the diagram and all, when it is present. So that's tube part. One lens is there, one lens is there. This is near the object. Here the human eye is put. So this is known as the length of tube. That's why this is put. Got it, Muniba?
Yes, ma'am.
Yeah. So V is D, VE is D. Now we have to calculate the magnification. V naught by U naught 1 plus D by FE. Same thing. V naught you'll have to calculate. First you'll have to calculate V naught. Okay. V naught will be calculated using the lens formula. 1 by F naught is equal to 1 by V naught minus 1 by U naught. So this will be 1 by V naught will be equal to 1 by F naught plus 1 by U naught. 1 by F naught is 4. This will be negative now because we are using the lens formula. Minus 1 by 6. And just calculate it, see what's the answer coming. I think this calculation will be easier. And length of the tube you can use directly. V naught by U naught is equal to L by F naught. Using this, you can directly get the value of length. Calculate and others also try. Why only Muniba and Zainab are active? I think these are just formula-based questions. And one more thing, class, in your board exams also, these kind of questions come. All these are extracted from your board exams. So remember the formula, derivation, formula-based question. Nothing much trickier will come in this. Okay. Write a telescope field description. Tell me the answers also. Like at least Zainab and Muniba are trying and getting the right answers. Yes, Aisha, your answer is absolutely correct. Put in the values. See, magnification also. Calculate magnification too. Value is right.
Ma'am, can you scroll up?
Zainab, this is the answer for which question? One, that one only, no? Which you said.
Yes,
Okay,
ma'am.
okay. Let me see the steps. Wait. Muniba, centimeter. Value is absolutely right. But centimeter थोड़ी आएगा. Magnification is unitless, okay?
Ma'am, can you scroll down?
Just check the length again once, Muniba. Just see, is it coming the same? Zainab, from where did you write the length for this? No, here length wasn't given. Like you've written the 16. From where did you get this 16? Like till here, the first part calculations are right. 16 का से? That is correct. 76.8. This part is fine. But just tell me, how did you manage this length? No, 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 no. Don't do that. See, this usually we take it as 16 and it is given as 16 only. But see, in this question also you will see mostly the answers are different. Don't assume and take it. Otherwise, see, there will be a discrepancy in the answer. Means it won't be completely incorrect. Like, see, it has to be around 780, yours is coming 70. So this would be the difference. So don't take it. Okay, usually we have understated. Many questions have the stated also. Assume that the microscope has the standard length. So just take a precaution while solving that. Otherwise, it is right and calculations and everything.
Yes.
No. See, the answers are around. See, V naught was 12, magnification 7, and length 19 point something. Okay. Let's start with the telescope calculations you can do properly. It can happen that the answers that I am sharing are wrong because I am just reading the written answers. I haven't calculated it. Okay. So you have the questions, properly practice it. Let's complete the telescope also. At least this topic will be over. Then the last topic, prism, will only be left. Okay. Telescope, how will you differentiate with the telescope and the compound microscope? Because here both the lenses are present. Differentiating factor will lie in eyepiece and objective. For the compound microscope, our object was so small and tiny that objective lens need not be greater. And we required a greater image than the object. Like if you're viewing bacteria in the under the compound microscope. or if you have a slide of anything that you have, any microorganism if you have. So microorganism is very, very, very small, not even visible by the naked eyes. So what we do, we put it under the compound microscope. Compound microscope magnifies it, which appears to us as very small though, but if you compare it with the object size, it is very greater, the image. Here, telescopes are usually used to view the celestial bodies, right? If I want to view the planets and all, I'll prefer a telescope. I won't prefer a compound microscope or a magnifying glass, right? So here also we'll have two cases. Case one will be final image is formed at least distance of distinct vision. Least distance of distinct vision means finally image is formed at capital D. So now the object is very huge. It's very great. So we'll have the objective lens aperture greater. Eyepiece will be smaller this time. Okay, this will be greater. This will in fact be smaller. So what will happen here is, let's now understand the ray diagram first. Object will be at infinity. कोई भी हो, you have any object that is existing, Sun, Mars, Venus, Jupiter, Saturn, any planet, it will be at infinity. We don't consider, because the rays are so far away. Infinity in the sense, see, they are light years, they are distant by light years only. It's just that the rays will come parallel to the principal axis. So according to our rules, the object will be at infinity. But object is distant. So that's why this has been shown as if this is at infinity. Means we cannot put object at infinity and get our diagrams properly. Okay. So whatever, see, let's understand this. The rays of light are coming. The light ray passes through the focus. Now see, not just passes through the focus class. The final image will be formed at the focus of the objective lens. Object is at infinity, so image will be formed at the focus. So according to this, if u is equal to infinity, then the image V naught, the first image, will be formed at infinity F naught. See, this is our image. This is the separation from the optical center to this. V naught is equal to F. Then the rays of light pass further to the eyepiece. Now human eye view it. So in comparison to that size, it's smaller, but at least we get an enhanced image of it and we are able to see. We are at least able to obtain the image. This is our final image. Okay. Now, here the image is formed at least distance of distinct vision, that is capital D over here. Now look, this must be, FE must be somewhere else. This is UE, where the intermediate act as the object. This is VE, capital D. That is the final least distance of distinct vision, because your image is formed there. Now, definition of beta and alpha will be the same. What was beta? The angle subtended by the image on human eye. Here is the image. This is subtending angle beta over here. So tan beta will be A dash B dash by this. A dash B dash divided by B dash E. Perpendicular upon the base. So perpendicular is this, base is this. What was alpha? And the angle subtended by the object on the human eye. Now see, object is subtending alpha. Let's say alpha is here. But this isn't making any triangle. Like how will we solve it from there? Because rays are infinite, rays are not reaching a point. So like can we solve that? So what we do, if you see this is a cross formation, so this angle will also be alpha. The reason is that vertically opposite angles. So this is alpha. Why are we using this? So that at least A dash B dash side is coming common. Some things are getting cancelled. How will we derive it? Now see, if we have this alpha class, A dash B dash divided by B dash O can be written C. For beta, understand this triangle for beta. Perpendicular by base. A dash B dash by B dash C. For this alpha, consider this triangle class. So this will be A dash B dash by B dash O. So A dash B dash will be cancelled from here. So what will be left, class? Magnification will be OB dash by B dash E. What was OB dash? OB dash is basically the focal length of the first one. Remember, V naught is formed, means image is formed at the focus. And what is B dash E? It's the object distance U. So F naught by UE. Now again, the problem comes with UE. We try to avoid these U, V and all. We try to put the focal lengths in our calculations. So magnification is equal to minus F naught by UE presently. Now we'll put our length formula. So sign convention will come along. Object is UE. Object distance, sorry, image distance is minus d, least distance of distinct vision. We put it in the length formula. 1 by v minus 1 by u is 1 by f. So 1 by minus d minus 1 by minus u is equal to 1 by fe. So when this goes on the other side, this is positive. 1 by ue is equal to 1 by fe plus 1 by d. Okay. So from here, see class, this is the value of 1 by ue. If we put it, I'll write it. See, this magnification that we have got can be written as minus f naught into 1 by ue. So for 1 by ue, I am putting this value minus f naught into 1 by fe plus 1 by d. Right? This is what can be written from here. 1 by fe plus 1 by d for this. Now I'll take fe out. So here this will be multiplied by fe. So that when you multiply inside, you're getting the same thing. So minus f naught by fe into 1 plus fe by d. I hope you're getting why fe is coming here. If I take fe common, from here 1 will be left. Here I'll have to multiply it with fe so that when I multiply and open up this bracket, see when I open this bracket, multiply this, it will be minus f naught by fe. Multiply to here, it will be f naught by d into f naught by fe. Right? Sorry, fe by d. Fe will be cancelled. Take f naught common, same value you're getting. So that's why we have taken this common class. Yes, tell me, the derivation of telescope is clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay then. Write it, class. Copy this first case, then we'll see the second one is very easy. That's done.
Yes, ma'am.
Okay. Case 2C. Here, this part is exactly the same as the above one. But see, in this case, the final image that is formed at infinity. Case 2 is basically final image is formed at infinity. So see, this alpha part will be exactly the same. This beta part will have a difference, that this final image V is infinity. So object will have to be at the focus. So UE will be equal to FE this time. This is equal to FE. This was already F naught. See, what was coming in our previous case? A dash B dash by FE. By UE was coming. So we had to change UE. This time there is no problem. From here F naught will come, from here FE will come. This was F naught earlier also. If you look at your derivation, A dash B dash, A dash B dash will be cancelled. OB dash by B dash E. B dash E is FE. So we'll write magnification as minus F naught by FE. That's it. This is the form. Okay. Optical instruments are clear to everyone?
Yes, ma'am.
Okay, then write it. Then let's start with prism after this, right? Done class or writing?
Done.
Okay, all of you have completed. Then let's start with prism. That would be the last portion of this. See, prism, when we have an image of prism in our mind, prism basically appears as if this is a triangle or a pyramid-like structure. But actually, it's not a pyramid-like structure. See, you have no three rectangular faces are there. Three rectangles, like one rectangle like this, one rectangle like this, and one rectangle at the bottom. So here, three rectangular faces are present. Okay. And the leftover portion, no, this is formed. The triangle, two triangles are present front and back like this. So here we have two triangular faces. Now the point tips, this is known as the vertex of the prism, the where the triangle and the rectangle meet. Okay, and the length or the side of the rectangle, this is known as the edge of the prism. And the rectangular surface is known as the lateral face. See, it's like a wedge-shaped structure. Not so lengthy like a wedge where we used to balance them, but this is a wedge-shaped structure. This is not a pyramid as if it comes to our mind. And see, this is the real picture of it. This is how the incident ray strikes on it. And this we'll study in detail in the dispersion of light, but this really occurs. I think there is an experiment where we put pins in prism, like not in the prism, means using prism wherever the light is reflected. Angle of minimum deviation, that practical is there? Yes, glass prism. Angle of minimum deviation is calculated using the prism wherever the minimum deviation, then pins are pointed, and then finally prism is removed and the lines are joined. So I think from that is a very common experiment as in your practicals. And see this point class, this is known as the angle of the prism. This is delta A, which is angle of the prism. Okay, write this much. Draw this. Then I'll discuss angle. Okay, angle of minimum deviation. So prism is what? Wedge-shaped portion of transparent refracting medium bounded by two plane surfaces inclined to each other at a certain angle, and that angle is known as the angle of prism. Like if we have an equilateral prism, equilateral prism. So this angle A will be equal to 60 degrees. It can vary. Thin narrow prisms, thick prisms, equilateral prisms. Right?
then
I'm done.
Okay, see, the angle of minimum deviation, just understand the figure first. See, this is the incident ray over here. This is the incident ray. This is the normal drawn to this surface. So the light ray will bend here. Let's say here with the normal to the, this is the refracted ray. This is the incident ray. So this becomes the angle of incidence between the normal and the incident ray. This is the refracted ray. So this will be R1. Now this ray of light goes further and acts as the incident ray for the upcoming surface, for this surface, right? So we take and assume this to be R2. This angle is known as R2, which is the incident ray for this one. And this is the normal for the surface. So normal and the refracted ray, we know it's, I told you this is known as the emergent ray also. These rays are also known as emergent rays. So this is angle of emergence. Okay. Now see class, if it wasn't for the incident ray and the medium changing, it would have had a different path. Do you agree that the incident ray would have gone like this? This would have been the path of the incident ray if the glass's refractive index wasn't affecting. Now see what is happening. The ray of light would have supposed to come like this if it weren't for the prism's refractive indices and the air's combined refractive index. So what we have right now, the ray of light is coming like this, right? If I take this, see, this was supposed to be the path. Now it is coming like this. So this angle, no, that is coming class. This shift in the angle. This is basically known as the angle of deviation. This angle is known as angle of deviation. What is this minimum? We'll discuss later. First, understand what is this? This is angle of deviation. Now, for our derivation purpose, I am marking this angle as this angle is angle 2. Let's say this is some x. Now class, according to the quadrilateral's property, opposite angles of quadrilaterals make 180 degree. That's why no, the complete sum is 360 degree, 180 degree this and 180 degree that. So I can say from here in quadrilateral ABCD, angle A plus this angle X, this quadrilateral ABCD, this opposite angle A, opposite angle X will be equal to 180 degree. So angle A will be equal to 180 minus X. Okay. Now class, if you look at this triangle BCD, in triangle BCD, R1 plus R2 plus X is also equal to 180 degree. R1 plus R2 plus X is also equal to 180 degree because of the angle sum property. So I can say R1 plus R2 is equal to 180 minus X. So what does this 180 minus X, A is also equal to this, R1 plus R2 is also equal to 180 minus X. Can I say R1 plus R2 is equal to angle A? See class, from here can we say R1 plus R2 is equal to angle A? This is one important conclusion, one important formula that will be. Did you get this? All of you?
yes,
Okay.
Yes.
I'll not discuss this further because this is a lengthy derivation. I need your full attention, and like right now, I won't be able to complete it. So in the next class, let's complete this chapter. Almost this chapter will be done. Okay. Wednesday we'll have the class now. Okay. All right then. X, you can take anything. X is an angle only. Okay, you can take it as theta, whatever is convenient. It's just a variable. All right. Okay then. Thank you, class. Bye.
Thank you.
Do we have class tomorrow?
Right now?
Tomorrow.
Tomorrow? Yes, I'll just confirm with your chemistry teacher.
Okay.
Okay.
Thank you.